regions. In one of the regions, we have a circle that's tangent to two of the lines at the points B and Q. Suppose this circle has a radius equal to r. In the region that's adjacent, we have another circle that is also tangent to these two lines. Suppose the tangent points are A and P, and this circle has a radius equal to s. Suppose that the length of PQ is equal to 14 units, and the length of AB is equal to 16 units. The question is, what is the product of the lengths of the radii? That is, what is r times s equal to? So how can we solve this problem? Let's go through it one line at a time. To begin, let's start out with just the line that goes through the points A and B. We know that these are points of tangency, so let's construct radii to these points of tangency. So we'll swing this radius to the point of tangency. Since it's a point of tangency, the radius will be perpendicular to the line going through AB. We will do the same thing for the other circle. This radius will be perpendicular at the point A. We know that the length of AB is equal to 16 units. Let's translate this line up to the center of the smaller circle. We know that this length will be equal to 16 units. Let's now connect the centers of the two circles. Let's suppose that this length is equal to the distance h. Now we have a right triangle. What's the other leg of this triangle? It will be the difference in the radii lengths. So this length here will be equal to s minus r. We now have a right triangle, so we must have that h squared is equal to 16 squared plus the square of s minus r. Let's now perform a similar construction for the other line. So let's remove this and let's consider the line that goes through the points P and Q. Now these are also points of tangency. So let's swing the radii to these points of tangency. We have this radius will be perpendicular to the line, and we'll do the same thing for the other circle and this radius. We have a right angle at the point P. Now we know that PQ has a length that's equal to 14 units. In this case, let's translate this line segment to the center of the larger circle. So this length will be equal to 14 units. Let's now extend the radius through the smaller circle and connect it to this line segment. This will exactly be equivalent to translating the larger circle's radius to extend this line segment. So we know that this length will be equal to s. We can now connect the centers of the two circles. Let's say that this distance is equal to h. We now have a right triangle where the legs are 14 and r plus s. So we must have that h squared is equal to 14 squared plus the square of r plus s. So this triangle shows us one way to calculate the distance h between the centers of the two circles, but we previously had calculated the distance h in the other diagram. Just to drive home the point that this value h is the same between the two diagrams, let's connect this diagram to the previous diagram. So let's get rid of this right triangle. Let's add on the line that goes through A and B. Let's go ahead and reconstruct the diagram that goes through A and B. Notice we are calculating the same value h in this diagram in a different way, where we have the equation h squared is equal to 16 squared plus the square of s minus r. We now have two equations that are equal to h squared. So let's just focus on these equations. Since both equations are equal to h squared, we can set them equal to each other. This gives 14 squared plus the square of r plus s is equal to 16 squared plus the square of s minus r. Let's simplify the left-hand side of the equation. We need to square r plus s. This will be equal to r squared plus 2rs plus s squared. On the right-hand side of the equation, we need to square s minus r. This is equal to s squared minus 2rs plus r squared. We now have an r squared term on both sides of the equation, so we can cancel out these r squared terms. We also have s squared on both sides of the equation, so we can cancel out s squared. On the left-hand side, we have 2rs, and on the right-hand side, we have minus 2rs. So let's add 2rs to both sides of the equation. This simplifies to be 14 squared plus 4rs is equal to 16 squared. Subtract 14 squared from both sides of the equation, and then divide by 4. So r times s is equal to 16 squared minus 14 squared all over 4, and this means that r times s is equal to 15 units squared. And that's the answer!